So my name's Luke Bolton. I am the Aircom Technical Sales Manager. So I've been helping customers for the past 10 years to put together solutions surrounding control systems, instrumentation, and data handling. And for the past 2 years, I've been working with Wisely Systems to roll out the Aircom product line. So before we discuss Aircom, we'll just review a couple of the points that Jack touched on there for the typical end node in the LoRaWAN ecosystem. So these devices are battery powered. They are going to take a measurement and they are going to send that data, whatever it might be, temperature, humidity, tilt. There's a variety of data you can acquire through LoRaWAN end nodes, but that battery powered device is going to take that reading, it's going to send it to a LoRaWAN server. So in North America specifically, this utilizes the 902 to 928 megahertz license-free band. And it's going to transmit that data potentially miles away. You're going to have a gateway there listening, ready to receive transmissions. It's going to pick up that transmission and it's going to forward it to the server. So the majority of these LoRaWAN end nodes on the market are for safe area use, and they are not rated for hazardous areas. So that's where we come in. So if we go to the next slide, please, Kareem. So Aircom is actually an acronym, and it stands for Advanced Intrinsically Safe Radio Communications. So not only can we be placed into the hazardous environment, we are actually an intrinsically safe product. So what does that mean? So when paired with an intrinsically safe sensor, that sensor can take a certain amount of power safely to be powered, and our Aircom device limits the amount of power that it sends to that device, and it powers it safely, and it mitigates any risk of a spark in the hazardous area. So we can be placed into Class 1 Div 1 environments in North America, and we're rated for ATEX Zone 0. So the Aircom end node, it has 5 analog inputs. These can be used to power 4 to 20 milliamp active and passive devices. We can bring back 4 heart variables. We can read voltage, resistance. RTDs and thermocouples can be wired directly into the terminals, as well as a potentiometer. We can even change our setup and have our analog inputs change to be digital outputs. And that opens up the way for control applications. One of our biggest control applications is in the natural gas industry, where we control the gas pressure at regulator stations. We've got 4 digital inputs. These can be used as a volt-free and more, and we can even carry out high-speed pulse counting at our digital inputs. We can use them as a cry-out. So let's say we're taking a pressure reading and we're sending it every 5 minutes. But let's say, we're monitoring a slam shut valve, the digital state. Let's say we send the transmission at 0 minutes and 5 minutes, but that valve closes at 2 minutes. Well, what the Aircom does, it will create a brand new LoRaWAN packet and send it immediately to get that data to the server, so we can see that change state for that valve straight away. So it doesn't need to wait until the next scheduled transmission. We have 2 RS485 channels, so we can actually use our end node to poll the data in another device's Modbus registers and take that data to the server. Some battery powered devices for the hazardous area are only battery powered, but we do have the ability on our device to supply power to the Aircom in auxiliary supply terminals. So this will need to go through an intrinsically safe barrier into the hazardous area, but this can be done with 12 volts DC. We can still leave a battery installed in the Aircom, and this can then be used as a fail-safe battery. But another really good feature of our end node is if you're just using the battery power of the end node in the hazardous area, let's say after 10 years the battery needs replacing, all you need to do is walk up to the end node, take the cover off, take the battery out, put a new one in, and it can be as simple as that when it comes time to change the battery. So, and the batteries can last a really long time, potentially up to 10 years. This just depends on the configuration and the application. And then if you've created your own network and perhaps you're bringing that data back over Ethernet around your site, it's going to cost you nothing to bring back this data, which is a real valuable feature of LoRaWAN in general. Okay, let's go to the next slide. So I just wanted to highlight a recent use case in North America. So this is a natural gas skid. So what's happening is there's a pipeline and there's a new factory that's being built. This factory is going to need a lot of gas. So what's happened is they've tapped into this pipeline. The gas is unodorized. So the gas comes onto this skid. It's odorized and it's metered before it makes its way into the facility. So the customer needed to monitor pressure, flow, and the data of the odorization. They wanted this to be a wireless device. They wanted it to be intrinsically safe. And the end user wanted to be able to view the data of this skid remotely on their laptop, tablet, and phone. So what you can see in the pictures here is it's a skid made by a company called Advanced Control Panels, an ISW manufactured the skid, and instrumentation by Vega and SICK and Wisey Systems is used on this skid. So at the top left, we can see a Vega diff that is being powered by the Aircom, and we're bringing back differential pressure. And then we've got two Vega bars supplying the inlet pressure and outlet pressure of the skid. And then we've got a FlowSick 500 that's giving us a corrected pulse for the flow of the gas coming through the skid. And then at the bottom right there, we can see the Wisey Systems NGEX odorizer that is precisely odorizing the gas. So if you just turn your attention to the bottom left of the slide there, you can see the I/O that's being utilized by just one Aircom. We've got 3 analog channels, 2 digital channels, and a serial channel. So we're utilizing 6 I/O channels with just one end node. If we go to the next slide here, Kareem. So let's just talk about the benefits of that. So typically, other end nodes in this sector, it may be a one-to-one. You may have one end node, one pressure, or you may have perhaps 2. So at a minimum, you would need 3 of competitor end nodes to be able to bring back the data from all these devices. So let's just highlight the benefit that Aircom brings to the table here. So if you install one Aircom instead of 3 of our competitors, that's going to save you capital when you're deploying at scale. You're going to need less end nodes overall to bring back the same amount of data. And what that means is it's going to put less pressure on your gateways and your server when all this data is being sent. When it comes to the battery replacement for these devices, some end nodes, you may need to take the instruments off, you may need to take them out of the hazardous area, and you may need to open them up and replace the battery. The beauty of the Aircom is all your maintenance technician needs to do is walk up to the device, take the cover off, take the battery out, put a new one in, and it's as simple as that. And if you've only got 1 to do instead of 3, it's going to save time and money. You also have the ability to add in another sensor at a later date if a new data point needs to be recorded. It's as simple as wiring in another instrument, using the app that's free to download from the App Store and Google Play Store. You turn on the Bluetooth channel on the device, you connect to the device, you update the configuration, and there you go. You've got another instrument that you can use, and it's really simple and can be done in the hazardous area. So Aircom can save you time and money long-term on these applications. Next slide, please. So just one other further update on the Aircom end nodes. We do have a new product that's available starting next year in North America. So it's our Aircom Mini. It's the same features we've discussed, just a smaller footprint, less I/O, and a lower cost option for different applications. So that's our Aircom end nodes. So these devices will collate the data, they'll send the transmission, and that data will go then to the gateway. So